find the nth term of the quadratic sequence. Right, quadratic sequences look like this: an squared plus bn plus c. So I need to find the value of a, b and c. Right, these are not going up in equal steps, but let's see. This one, the difference between 6 and 9 is 3. Difference between 9 and 14, 5, 7, 9. Difference. Right, so now put these expressions down. Circle these first. So that one is related to 2a. This one is 3a plus b, a plus b plus c. And in a previous video I've shown you where these came from. So let's work with this first one here. 2a is equal to 2. 2 times something to give me 2. Right, now this bit over here. Well, a is already 1. We know a is 1. So 3 times 1 is 3. Add something to give me 3. Well, b is 0. Right, last one. We have a plus b plus c equals 6. We know a and b. We know a is already 1. B is 0. C is what I'm trying to find out. So C is 5. So here we found the nth term. A is 1. So you can just write 1n squared or just write n squared. B is 0. So don't bother writing the n part. And then C is 5. There you go, that's the nth term. And you can just quickly check to see if this works. If you replace the n with 1, 1 squared is 1 plus 5 is 6. Replace the n with 2 now. 2 squared is 4, 4 plus 5 is 9. And let's do one more. Replace the n with 3, 3 squared is 9, 9 and 5 is 14, and so on. Right, just looked at numbers going from smallest to biggest, and it is a quadratic sequence. But what if I had the numbers going the other way around? The 30, 21, 14, 9 and 6 there. Let's see what happens now. So to find the nth term, it's actually going down. The numbers are going down, decreasing. So let's take away 9, take away 7, take away 5, 14 take away 5 is 9, and so on. Take away 3, 9 take away 3 is 6. Right. Here, looking at this sequence, the numbers are actually going up. The numbers are getting bigger. So if you think about the number line, minus 9 is on the far left hand side, and minus 7, minus 5, minus 3, and so on. So the numbers are increasing. So it's positive 2s. They're going up in 2s. Right. So now put those expressions. A is equal to 2, therefore a is equal to 1. 3a plus b is equal to negative 9 this time, where a is 1. A is already 1, so 3 times 1 is 3. Add something to give me negative 9. Well, 3 take away 12 will give me negative 9, so b is negative 12. Now this one. A is 1 already. B is negative 12 plus C is equal to 30. Right, 1 take away 12 is negative 11. Negative 11 adds something to me 30. 30 and 11. 41. C is equal to 41. So my nth term is, if it's going to be in this form, an squared plus bn plus c, well, a is 1. That's just n squared. B is negative 12, so that's negative 12n, and C is, well, that's a positive number, so it just stays as positive 41. That's my nth term representing this sequence. Right, just a quick random test to see if this is okay, what I've got. Shall I try and find, I don't know, which one first, second, third, fourth, fifth? Let's go for the fifth one. Fifth one is 6, so if I replace a 5 into my expression here, I should get 6. I'll just quickly use a calculator. So 5 squared minus 12 times 5, add 41. So I'll just replace the 5 where the n is. Press the equal button, hopefully that's going to give me a 6. There you go. You're probably wondering why I put brackets around the 5. I could have just put 5 squared, but I'm kind of used to this because let's say I was supposed to substitute negative numbers in there. Say negative 5. Now, negative 5 squared is 25. That's what I get as an answer. But if I didn't use the bracket, let's say I go back, don't use the bracket, just do negative 5 squared, I get a different answer. What's really happened is this. I'll tell you what's happened. It's ignored the negative to begin with. It's done 5 squared, which is 25, and then stuck the minus in front of it, so it becomes minus 25. So that's why I prefer, as a habit, I just do this as a habit. I always do that.